Hello. In this session, we're going to examine lightweight views, which are fairly new to StarTeam. We were introduced a little less than a year ago. Working on in the 17.0 release. I am working with the 17.1 client right now. I'm going to start by creating a new project on my local host. And that's my local server. I'll call the project Delta 2. And the reason I'm doing that is because I'm going to actually map this project to an existing working folder on my disk, which is the source code for our Delta 2 project. I want to actually create a project with data in it, sufficient number of files, folders, etc., so that I can explain a fairly um, I can explain the whole concept of lightweight views to quite a fair amount of depth. There's 4,500 files in it. That's a fair amount to say the least. I'm going to check all these files into this project, into the root view. Hopefully it's not going to take us too much time, but we'll kind of see where we get with that. So whilst this is going on, let's talk about what lightweight views are. We've traditionally had branch all views, we've had reference views, we've had um, floating views. We've, for the most part, moved away from floating views. We still have customers who use reference views. The idea of a reference view is it starts out being an empty view but acts as a reference to its parent view. And there's nothing actually in the reference view, but it always shows you the state of what the parent looks like, depending on whoever's looking at the reference view. And it's meant typically to deal with things like setting access rights so that people who use reference views can be targeted to see only certain pieces of data that exist in the underlying parent view. In the same fashion, people who work in the reference views will work in areas of the data where the changes made to the reference view, to the files made in the reference view, propagate directly back to their parent. So lightweight views start out similar to reference views, at least insofar as when you create a lightweight view for the first time, there is no real physical data created on the server. There is no branching or sharing of any of the files in the parent view or from the parent view to the lightweight view, except for the root folder. So the root folder of the parent view is shared down to the lightweight view, and that is really the only entry that's created in the database to describe that lightweight view in terms of the underlying view members, the root folder. The view itself has a flag on it that identifies it as a lightweight view. What happens when I start using a lightweight view? If I create a lightweight view and then start using it, the moment I actually open that lightweight view, it behaves exactly like a reference view. I see the exact architecture of the files and the folder trees in the parent, just as if they were in the lightweight view itself. So what I see is effectively a mirror of the state of the parent. Our operation is just completed. So let's, without any further ado, go ahead and create a lightweight view. To create a lightweight view, I'm going to go to project properties. Before I do anything else, I'm going to either enforce or disable check and change packages. It really doesn't matter uh, from the perspective of the lightweight views, whether the change packages are enforced or they're disabled. It does matter that you cannot leave it enabled, because if you do, it'll refuse to create the lightweight view. So actually, let's do that. Let's leave it enabled and go ahead and try to create the lightweight view. So I'm going to create a lightweight view, which would be a child of this view. And I know it's going to fail, but we're going to see it go ahead and fail anyway. Lightweight views cannot be created in projects which enable workspace change packages. The keyword here is enabled. They must either be disabled or enforced. So since we know that, we will cancel out from here. We'll go back to the project properties. We will explicitly, we'll go back to project properties. and we will explicitly enforce lightweight views now and enforce check and change packages. Having done that, we can now come in and create a lightweight view. As a child of this main view. And let's read this text. A low-cost throwaway reference branch of the parent view targeted for file folder add, check, and move delete operations, typically best discarded after a promote. So I'm just going to leave it at this pointing to the same folder, which is where I started from, and it's gone and created the view. So it happened very, very fast. Admittedly, this is on my local server, but even if it were on a remote server, the fact of the matter is the creation of the view from the database point of view means create one record for the view itself in the view table, create one record in the view member table for the share for the root folder, and that's it. But if I look at the view, now I'm looking at the lightweight view, I can see the exact view hierarchy and the exact file and folder hierarchy of all the files in the view, but these are not the files in the lightweight view. They look like them, it's a mirror, they're actually files in the parent. If I looked at the reference tree, the file actually shows up as the reference from the parent. So why is that useful? Well, until such time I actually perform an operation in the lightweight view, the view itself is extremely sparse. I don't have any view members other than the root folder. So if I go ahead and I make a change in my lightweight view, I'm going to edit this file, actionset.java, and I'm going to put in a comment that says set an action. The moment I do that, this file goes to a state of modified, and I'm going to check this file in. Let's say that my goal was to perform a quick dirty change. Somebody asked me to fix a bug, and I'm going to follow my normal process model. I'm going to create a change request associated with this. I don't have to, but typically with StarTeam, the whole value proposition behind StarTeam is using process items, using process models to be able to check in and check out files in conjunction with their process items. So we have not only audit trails, but we have the workflow associated with the process items, the change requests, etc. So fix a bug in action set. Come over here. I've got this modified. Bear in mind, it's not changed. It's changed on this, not in the tree, not in StarTeam. I'm going to check this file in, link it to the process item, and mark the process item fixed. And done with my bug fix. So the moment I did that, what StarTeam did internally was it shared this file down from the parent view to the lightweight view. And after finishing the share operation, it then checked in the change. So now the set of view members in the database for this view is two, the share for the root folder and the share for this file. But I also have all the rest of the process rules associated with the StarTeam process rule set still holding true. So I have a process item in the lightweight view. I have the file that's changed. I have the change request that was fixed. And I can now take this and I can run a view compare merge session and promote this fix when I'm ready, of course, after it's been reviewed or verified. I can go ahead, promote this file up to the parent view. And now that I'm done with this, I actually have the option. I can, if I go back and look at the parent view, I'll see that my change request has also showed up there because it's when I ran the VCM promote operation, the change request got reverse shared up and the fix went up as well. So if I go to the parent view and take a look at the file that was just checked in, I could have just looked at the file that was in a merged state. Here's the file. I can look at its differences. This is now in the parent view. I can look at its history and compare its contents. And as you can see, this change is the one that I'd made in the lightweight view that's simply been pushed up, propagated up to the parent, right? I set an action. So the point with lightweight views is that because of the sparse nature of populating view members only as they are checked in, moved, deleted, or whatever, and the sparseness is achieved by simply displaying a mirror of everything that's unchanged with respect to the parent, and then subsequently um, sharing them down only on an as needed basis. So when you do a check-in, when you do a move or a delete or an operation, which is always within the context of the change package, if change packages are enforced, of course. So given that this is true, lightweight views now become fairly inexpensive to use and to discard if we would so prefer. Now, since I've already caught up with my change to the parent view, I can actually go right ahead and delete. I'm not going to do that, of course, but I can go ahead and delete this lightweight view. This is from a VCM process model as well. I could very well have had this project view tree show two or three other people, Paul's lightweight view, Jim's lightweight view, Mary's lightweight view, all underneath this. Each of them could be working with their lightweight views, promoting their bug fixes as they were ready to the parent view. At some point, I want to catch up with the changes that other people have made. In that case, I can run a view compare merge and rebase everyone else's changes at a full view scope to my lightweight view. And the moment I do that, if there are any changes, in this case, there aren't going to be any, but if there were any changes, I would be able to actually catch them and resolve. I would be able to get them down and catch up with them in my lightweight view. So in this case, the only change is the mark resolved, which isn't terribly interesting. It simply says that the two revisions are really the same revision. The content is identical. So there's nothing really that I had to do in this particular case. But if I choose to now go ahead and delete this lightweight view, then it's a very quick, fast mechanism for um, working with um, lightweight views, um, throwing them away when I'm done with them, associating individual lightweight views with individual process items. This, in a sense, becomes a mechanism where I can say for a given project, I don't necessarily have to throw anything away. I may choose to create lightweight views per process item that I've been assigned to or working with. So I'll create a view called a fix for CR12345, and this is also a lightweight view. Refer CR12345. Once the view is created, the other thing that's interesting about lightweight views is that when a lightweight view is created, it always starts out without any change requests. So if I were in the parent view and CR12345 actually existed there, when I came down to the lightweight view, I could explicitly share, so I should have done that in the parent view. I can explicitly share this down or move this down. I can either move it or share it down to the child view to its root folder. So now I'm in the child view. I've got a CR that's open. I've got to work on it. I'm going to come over to the file tree. I'll find a file that I need to work on. Make a fix to this file. Check the fix in. Link it to CR12345. Of course, I'm showing a very simple fix, one file. The fix could propagate across multiple files, and use the process item to promote the fix up to the parent view. Now, even though I'd claim that we can easily throw away lightweight views, we may choose for audit purposes not to throw them away. And that's perfectly okay as well, because they are sparse. They don't occupy a lot of space in the database. Each lightweight view effectively maintains only shares of the files that were worked on in that lightweight view and or changes that were rebased down to it. So I could end up with multiple lightweight views underneath my root view or underneath any view in my project. And each of those could be associated with one process item at a time, or two, or whatever mechanism as an organization would like to work in and with, to be able to manage its changes, manage its process, and manage its process items and defects in conjunction with and in association with the views. So you can easily see how this could extend to have each lightweight view effectively become a little change bucket associated with a given process item. There's one and only one important rule to be aware of with respect to lightweight views is lightweight views cannot branch off any other views than branch all views. So in a view hierarchy in which, let's say, I cannot create a lightweight view as a child of a lightweight view. I have to actually go back to the parent. And let's say I branched a release view of the parent. So I've got a release view, and I'm working in my release view. I've just put this out to the market. As a consequence of that, once it's out there, someone reports a defect. I need to fix that defect and ship that defect fix out back to the market. The only way I can do that, of course, I would create a lightweight view underneath the release view. Let's say I make my bug fix in here. I create a change request. Fix my bug, whatever it is, my defect. Check this in against the CR. I'm still in my lightweight view, and now I can take this, propagate it up to its parent. commit that in the parent view. So the parent view has now got the release defect fixed, and I could issue a new patch release at that point. And once I get up to the release view, I've got the patch, the bug fix, if you will, in the release view. I do not have it in my work in progress view, which is my main view. So I can go right ahead and promote that there as well, so that the main view then catches up with the defects that have been fixed, um, coming down from release views as well. So what does my view tree look like at this point? It's kind of an important question to ask, isn't it? I have a main view here. I have lightweight views here in which people can work and make their changes, uh, fix individual defects or little enhancements. All of these are throwaways. I have a release view, which is a branch all view, branching off the main view that was created at the time I was ready to do my work. And then I can have lightweight views underneath that, all of which will propagate, which would be used to propagate defect fixes to release views, and then from there up to the parent views. And since the lightweight views are sparse and they are effectively throwaway, I can choose to either have them catch up with the defects, if that's a model I prefer to work with, catch up with the fixes, or I can choose to ignore them and go off and create new lightweight views, since lightweight views are very cheap. Well, so much for this session, and I hope this helps. Take care. Bye-bye.